We're continuing our exploration of internal developer portals with this second video on port. If you haven't watched the first video in which we introduced port and set it up with GitHub, PagerDuty, and scorecards for production readiness, please go watch that video first and come back to this one after. In this video, we want to explore another important pillar in internal developer portals, self-service actions. We'll build an EKS cluster, scaffold a Node.js app, and deploy it into this cluster. Port does a great job of simplifying the process with a rich front end and very flexible backend automation tasks. If you've seen some of my Backstage videos, you'll notice that I was only using GitHub Actions as the backend automation engine. That's because it comes out of the box. Some of you asked for integrations with Jenkins or GitLab instead, and you'd have to really code that into Backstage by creating a plugin. Anyway, let's get started with this video. Okay, for this video, we're going to follow this guide, create an EKS cluster and deploy a Node.js app. And basically, as I mentioned earlier, we're going to create an EKS cluster, scaffold a Node.js app, and then deploy this app into this EKS cluster. So some of the prerequisites you can see here, you need to have the ports GitHub app installed, which if you followed the previous video, you already have that. Also, you need a blueprint representing your repositories. We call those services that we also created in the previous video. A repo to contain your action resources. That one I have forked, which you can also fork from mine, which is over here. We'll talk about this as we go, but it has a bunch of workflows here. And we're going to use GitHub as the backend automation engine that we'll see within our self-service actions. So the workflows are right here. And I have our self-service actions defined as .json files in this folder. And that should get us going. So you can go ahead and fork this. I forked this, as you can see from the guides GitHub repo, but made some changes. So you can go ahead and use my fork. All right, so let's go back and get started. The other thing is we need to add a few secrets. So if you go into my repo under settings and secrets and variables actions, take a note of these because these are the secrets that you're going to need inside of your own GitHub repo. So we're going to need the AWS access key ID. Remember, we're creating an EKS cluster. We need access into AWS. So we need the credentials, the access key ID, the AWS region, the secret access key. And then we need a creator token, which is a GitHub token. So we can create GitHub repos and delete a repo and so on. So you're going to need to create a personal token in GitHub. And then you need your port client ID, port client secret. Again, I showed you in the previous video where to get that from. And then your Terraform API token, if you're going to use Terraform Cloud like I'm using in this video. So you need a way to be able to get GitHub Actions to log into Terraform Cloud. So we're using this Terraform API token. And that's it. Let's get started with our guide. First things first, we need to create blueprints. So we need a region blueprint and an EKS cluster blueprint. So we can just grab those from here, copy that, and let's jump into our portal. And in here, we're going to go under Builder, and we're going to create a new blueprint. Go to Edit JSON. Let's select that, delete it, and paste ours right like that. That should create a region blueprint like that. You can see in here, it has just a link property. No actions, no scorecards defined, no relationships as well. So now let's go ahead and do the second one, the EKS cluster blueprint. Let's copy that and add a new blueprint. Edit the JSON, paste it in here, save that. And just like that, so easy, we were able to create our two blueprints, and we can see there's a relationship between them here. Here's our EKS cluster blueprint. It has a few properties, tags, name, role, ARN, version, endpoint. You can see you can add descriptions, the cluster endpoint, and we have another property here, region or a relationship, a region. You can see it's tied to region. We have no actions yet. We have no scorecards yet. So that's perfect. If you go to the catalog, you can see now we have 2 pages. We got the EKS clusters page and we got the regions page. So in here, we can manually add some regions. So you can add, let's call this US East 1, for example, where we're going to deploy our EKS cluster. Okay, create that. And we can create another one, US East 2, for example. And be careful, make sure that your identifier isn't created automatically, because then there's an issue with these underscores. You need to have dashes for your region. So make sure that is defined correctly. So the identifier and the title can be anything, but the identifier is important here. And then the next one is just US West, maybe US West 1. Copy that here, create that. And now we have 3 regions. That looks great. Let's go back into our guide. It says to create a file called manage-eks-cluster.yaml in the GitHub workflows, which we already have. If you fork the repo, you're going to already have that. And then we need to create a port action against the EKS cluster blueprint. This port action is the create EKS cluster action. I have it again inside of our repo, so we'll grab it from here. Let's go back to our code and let me show you the first workflow, and that is to manage EKS cluster workflow here. And while we build the EKS cluster, we'll go back and look into this. But what we want to do here is the create EKS cluster.json. So this is the self-service action that we want to grab. So let's copy that. Again, it's .json, so it's very convenient to just grab it like this and paste it in here. And here you're going to go to self-service, new action, go to edit JSON, and paste it like that. Okay, really quickly before I hit save, you can see a few things here. Oh, this is the identifiers EKS, create EKS cluster. Title is create an EKS cluster. We give it an icon, Amazon EKS, description. And then we have a few user inputs. So we've got the cluster name and we've got the region here that you need to provide as a user. Remember, we're building this for our users. In this case, our users might be developers, or they might be also other platform engineers that we're building for, depending on the scope, depending on the permissions that you're going to give inside of port. So both cluster name and region are required, and this is the order we want them in. The blueprint identifier is EKS. The invocation method here really is the workflow inputs that are going to get passed to GitHub Actions. Because remember, we're right now building the front end, and the front end needs to pass the inputs that the user is going to put in to our back end, which is GitHub Actions. Okay, and here what we're saying is that our back end is actually GitHub, and I'm providing my organization name. You'll need to change this, and also the repo where this lives in, where the actions, the GitHub Actions live in, which is my repo here. And you can see this is the repo name. This is where all my GitHub workflow actions live. Okay. Here we have some conditionals on the inputs that we can see, and we can grab a few things out of the inputs out of the payload, which is really interesting. I'll show you later. There's also a port payload that you can send along to GitHub Actions, which is really neat. And you can grab quite a few things, like the status is triggered, resource type is run in this case, who triggered this, which is me in this case from port, some context, what blueprint, what entity is being sent, the run ID, and a few other things. Here's another payload that's under port payload that's giving also more information, and all this can be, you can parse it in GitHub Actions and do all kinds of things with it. Okay, so that's it. Let's save. Perfect. And now we have our create an EKS cluster, as you can see, and you can go ahead and edit that. You can edit in JSON, which we just did, or you can edit in the form of a form. You can see here the icon that we used, the blueprint that we're tied into, the EKS cluster blueprint that we just created. The user form here, we've got cluster name is a string, region is an entity selection, which is great because we've already created 3 regions. So from an entity selection, it knows what regions are entities inside of port that we can grab from, which is very cool. That to do this is much harder in Backstage. And then you can see the backend portion. The invocation type is GitHub workflow. There's a bunch. So we've got triggering a webhook URL, which is like a catch-all last resort. You can just send a webhook somewhere. You can send if I click that, and you can see what we can do. We can send the post method, a delete, a patch, a put, and you can send this anywhere. You can trigger a pipeline somewhere, right? If it's not covered by GitLab, Jenkins, or GitHub, we have also Azure pipelines, right? There's also a Kafka topic. So a lot of flexibility here. And again, if none of these work for you, then you can just issue a webhook out to another URL somewhere else, and you're good to go. So back to our GitHub workflow. Now that I messed this up, let's cancel out of here. Discard changes, and let's go back in real quick. Oops. Edit this. So you can see here, once again, my organization, my repository, the workflow file name that's going to get issued, which is the manage EKS cluster.yaml, which is this one here. So basically, we're going to trigger this in the backend. We're going to trigger this particular workflow in GitHub Actions. And now let's go ahead and create our EKS cluster. So you just click create. Now we're a user, right? So we're a user of this self-service action. So the cluster name, we can call it something here. I will call it dev EKS maybe, or just dev. Select the region. I'm going to use US East 1, execute. And you can see on the right-hand side here, we've got creating this or creation in progress. Click on create an EKS cluster. And you can see it started a few seconds ago. We have a job link. We've got some log stream here, which is neat. Initiating the creation of the EKS cluster dev. Affected entities, don't have anything here. You can see the form inputs. So these are the inputs that came in when I submitted, right? Cluster name was dev. I submitted the region, and with the region, you get a bunch of things, right? The properties of this region, if we have any, the identifier, US East 1, the title, and a bunch of things that are pretty cool because you can send this over to GitHub Actions and do something with that over there. Now, this one here is the payload that actually got sent over to GitHub Actions. So you can see here the workflow inputs, that's really what got sent over. The cluster name is dev, the region is US East 1, and port payload, okay? So in the port payload, we sent a lot of things here. You can see we sent the user, the triggered by, you can see my user ID, my org ID within port, my email, first name, last name, picture, providers, a bunch of things that you can use within your GitHub Actions. And if we look at our GitHub Actions, basically you can click on the job link here, and this takes you directly to the action that is running in GitHub, the workflow. So if I click on that, you can see the job. So we're already on our way to implementing this in Terraform. So I can see here, so we've set up Terraform, we've run Terraform init, Terraform format, Terraform validate, and then Terraform apply is running right now. You can see this is all the things that are going to get created, a bunch of resources. These are all being built right now, right? So we're in the middle of building our EKS cluster with Terraform, and I am using Terraform Cloud for this, and I'm using it in CLI mode and also in local mode. So if I go into Terraform Cloud, if you're interested, we can go into our workspace, and I'm already in the workspace. You can see the execution mode is local, which means that everything is run inside of GitHub Actions. I'm not using any of the runners inside of Terraform Cloud. I'm just using Terraform Cloud to store the state file there. That's it. So we'll wait until the cluster gets created, and then we're going to start working on scaffolding our Node.js app. But in the meantime, I want to show you my Terraform code real quick. just to get an idea of what's going on. So if you go under Terraform, the Terraform folder, there's only 4 files. We've got the terraform.tf file, which has a few providers. Here I specify Terraform Cloud and the workspace that I'm using in Terraform Cloud. And then here I've got the providers that we're using. So AWS, Random, TLS, Cloud Init, and Port. So Port has a Terraform provider, which you would expect from any decent offering, that you would have some sort of integration with an infrastructure as code offering like Terraform. So you can go ahead and take a look at Port's provider in the Terraform registry. So if you go into Terraform registry and just type Port, something like that. Here, let's go into Terraform registry and let's look up Port. It's called Port Labs. So here we go, Port Labs, and we have a provider for us here. You've got the documentation. You can see all the resources that we can create. And we're going to create this this port entity in here. So I'm going to show you what we're doing in just a minute. So if you go into our Terraform main.tf, you see the provider AWS and the provider port. And all this I've done before in when we created the EKS cluster with Backstage. So nothing new here. We're creating, or we have a module EKS, we have a module VPC, and we've got a module IRSA EBS CSI for CSI add-on. Here's a CSI add-on you can see. And then we've got this new resource, which is a port entity resource. And you can see here the identifier, the title, the blueprint, and a few other things, which is really cool because once this is complete, we're going to have an EKS entity inside of Port that you'll see that's created here directly from Terraform, which is amazing. Finally, we have an outputs, of course, an outputs file that's typical, and we have a variables file as well. You can see we have a port run ID that we can feed in if we wanted to. So that's also available to us. Now, finally here, what makes all the magic happen in the back end, which is the actual GitHub action workflow itself. This one's called Manage EKS Cluster. And here we can see that we're running a workflow dispatch and cluster name, region, and we've got action and port payload as well. In this case, action is really, the default is apply. We can, and I'll show you at the end of this video how we can destroy our EKS cluster by providing an action of destroy in the inputs. But really, cluster name, region are the 2 inputs, plus the port payload are the inputs into this GitHub action workflow. Then we have our jobs here. You can see here we have a bunch of environment variables that are grabbed from the secrets inside of GitHub Actions. So the credentials for AWS, the port client ID and secret to access port. We're checking out the code, creating log messages, which is really neat. So some feedback that comes back into Port. I found this very difficult to do with Backstage. Again, you have to write a plugin or look for a plugin. So creating a log message is in here, and the first log message is initiating creation of EKS cluster that we just saw here, initiating the creation of the EKS cluster dev, and the input we're passing in through here, the inputs.cluster name. Then we've got our setting up of Terraform with the secret TF API token for Terraform Cloud, initializing Terraform, formatting Terraform, validating Terraform, and then Terraform apply. And you can see we're running Terraform apply auto approve. And here we've got the environment variables that we're going to run with. So the cluster name, the region, and the port run ID, we're providing those as TFVAR environment variables into Terraform. We also have a Terraform destroy here, which we're not using in this particular instance. And at the very end, we have a create a log message post action that will give us once again, a log message. EKS cluster creation has completed and gives us the name of that cluster. All right, so let's see how far we've gone. I think we're still creating this. This takes about maybe 25 minutes to 30 minutes to get our EKS cluster up and running. So we'll pause the video and come back once this is ready. We have completed successfully here. Terraform is done. added 63 resources. Here are some of the outputs, the cluster endpoint, cluster name is dev, cluster security group ID, region, and that's great. So GitHub Actions is done. If we go back into our create an EKS cluster self-service action, we can see that it is also successful, and we have finally EKS cluster creation has been completed. So that is done. Perfect. And we can go back and look at our catalog, and inside the catalog, we have the EKS cluster. We can see the identifier here. So this entity has been created. And again, the identifier, which is the ARN, the role ARN is right here as well. We have US East is the region. Here's our endpoint for the cluster. So all this information got brought into port, which is really good. And this was again using the Terraform port provider in here. We're able to feed this information into this entity. And if we go into the AWS console, we can see our dev cluster is created. As you can see here, we've got all the information about the cluster, resources, compute. Our add-on is also available. So that's pretty neat. Let's continue with our guide. Now we want to scaffold a Node.js app. We're going to scaffold it first with all the files that it needs. And then finally, we're going to deploy the app onto this EKS cluster. Okay, so let's go ahead and create a new action. So we can do that by going into our port scaffold and app.json file here. Let's copy that. And let's go in here and create a new action. Edit JSON. Let's paste that in here. And let's save it. And that creates a scaffold app. And notice that there are three categories. It's a create action, day two operations action, and then a delete action. So we've categorized it into those three categories, where if you're creating something for the first time, that's a scaffold, that's a create action. If it's a day-to-day operation kind of thing, you'll put it under day two operations. Or if you're deleting a repo, deleting the EKS cluster that we'll see later, you can put it under the delete actions. So let's go ahead and take a look at what this built for us, the scaffolding app. And here we have, again, the create action that I told you. So you can choose day two, delete, or create. We're tying this to the service blueprint. And you can see the form that we have here, the project name, the repo name, a template, a description. From the backend perspective, we're using GitHub Actions again, a workflow. And I'm specifying once again my org name, my repository name, and the workflow file name, which is scaffold app.yaml, which we'll see in a little bit. And then finally, the inputs that you'll expect into the GitHub workflow, right? So I've got the project name, repo name, template, description, and the port payload as well that I want to send over. Okay, let's go ahead and scaffold our app. Hit create, project name, my new cool Node app, repo, my cool Node app, let's say. And then choose a value Node.js. There's Python also, but we're choosing only Node.js here because I haven't wired anything for Python, just left it there as a placeholder. Description, this is my first Node app. Execute. And notice that it created a scaffolding app here, and it's already gone through and finished our GitHub action. You can see the log here, my new cool Node app, creating ECR repository, creating repo for the app, committing the new app files, and then finishing the scaffolding. Once again, you can view the inputs that we pushed to GitHub Actions. You can see the payload as well. And we can go into the job links and we'll see the actual GitHub action has completed successfully. If we go back to our catalog, we can see under services, last updated, my cool Node app shows up here that we just created. So we can go and jump into the URL. And from here, you can see a bunch of things here. We've got a manifests folder. In the manifests folder, we have a deployment.yaml. And here, everything is filled in. We're using something called cookie cutter. We'll show you in just a minute. But you can see the deployment has a name, replicas. All this is ready to go, so we can deploy this into our EKS cluster. So there's also a service for us as well. And it's using type load balancer. So that's great. We can see a bunch of other things like the Docker file that's used for this node applications is all set, a README file, even an index.js, the package.json. All this is ready to go with a port.yaml that allows us to attach this as an entity, which we just saw inside of port. But this is basically showing you the workflow that a developer will use. They can just hit the scaffold action and they scaffold a new Node.js. And as platform engineers, you can specify golden paths in terms of how we as an organization build Node.js apps. This is how we do it. And we already have certain deployments ready to go. And then the developers can use those scaffolded apps and deploy them into an already existing EKS cluster, for example, or another Kubernetes cluster. Okay, now let's take a quick look at some of the configuration for the scaffolding app. So if you go back to our code here, you can see we have this app templates folder. And in here, we have this README for cookie cutter templates for new projects. You can go through and read about it. But in here, we have our Node.js. We have a cookie cutter.json file that you can see here. It has some defaults. And then we've got a cookie cutter folder here. You can see what we saw before. So we got the Docker file. We have, and this is what got pushed into our new repo. We have a README here, and you can see the cookie cutter template. This all gets replaced. And we've got our index.js file. We have our package.json and port.yaml. And again, the cookie cutter template here, all this gets replaced. And our manifest, same thing. We got a deployment with the template and the service.yaml with the cookie cutter template. So all that got created for us, and it's all done again by the GitHub action. This time it's the scaffold Node.js app here, which we can see the content of this one. If we go to GitHub workflows, scaffold app.yaml. Once again, we have our inputs, project name, repo name, template description, and the port payload. And the environment variables are the port client ID and client secret that we need. Here we're creating a log message that we've started the job here, starting the scaffolding of the app, checking out the code, check if the repo already exists. And here we're creating a log message, again, creating the ECR repository. So we're creating an ECR repository in AWS, configuring AWS credentials, logging into the AWS ECR, creating the ECR repo here, as you can see, running the cookie cutter. Okay, so this is being run, and the values here are fed in our front end that got passed over from port to GitHub workflow, creating another log message, and then creating that GitHub repository. So reaching out into GitHub and we're creating that repo, one more log message, and then committing our files into that GitHub repository. And finally, a last log message into port. Perfect. So if we go into here and look for ECR, we should be able to see a new repo inside of AWS. And here we go. My cool Node app, you can see here, is available for us. No images in it just yet. The last portion here is to deploy the app into our EKS cluster. So you can see here, we need to do two things. We need to create a port service action to deploy to EKS. And then we, of course, need a workflow for that, a GitHub workflow. So let's jump over here into my code, and under deploy to EKS action, I'm going to grab that and back into port. Let's create a new action, add a JSON, paste that. All right, so we can go ahead and execute this, deploy to EKS. And we need two things. We need the EKS cluster, which was already created for us. So this is an entity that we can just select, very easy. So that's our EKS cluster called dev. And then the repo. So the repo, as a developer, I need to know which repo I scaffolded. So I do know the name of it. So I'm going to select it here, my cool Node app that we just created, and execute. Let's go ahead and see what happens. You can see that this is already executing in the background. It's in progress. The payload, once again, here, we're sending the cluster ARN and we're sending the repo URL. So that gets processed in addition to port payload, of course. Now that gets processed by our GitHub action. We can see some of the log messages coming out here. If I click on the job links, you'll see my job. Oh, it's already done. You can see everything is done here. We did a few things. We configured AWS credentials, logging into AWS ECR, building and pushing the Docker image. We're notifying port, extracting the cluster name from the region, the name and region from the ARN, deploying to EKS. Once again, notifying port, post login to AWS ECR, and post configuration. So that's that. So now what we can do is take a quick look at our ECR registry, refresh, go into our repo name, and here we go. We have images that we've pushed in here, which is great. So all these images are what we're going to use to deploy our application. So let's now grab or get into our EKS cluster. So let's execute the command AWS EKS update cube config. And the name is dev for the cluster and the region is US East 1. Okay, now I can see my namespaces. Let's go into the default namespace, clear that, run kubectl get all. And I can see I already have 3 pods running. My application, I have a load balancer here. Yeah, that's running my application. Let's see if we can access this. There you go. Here's our brand new cool Node.js app giving us a hello world. But this is already installed, deployed. Everything is running very nicely. And from this point on, the developer now has a fully deployed application with the scaffolding. They have a GitHub repo. They can start to work with that. And every time they need to deploy, they can just run the deploy once again, and they're good to go. One last thing is we can actually delete the cluster similar to the way we created it. So you can create a new action and you need the JSON. And from here, we have it actually under port delete EKS cluster. So you can grab this, go back in here, save that. And it will show up under delete actions, delete an EKS cluster, click delete, choose our dev cluster, region is US East 1, click delete. That should start off our process here. And of course, again, this is going to send the job over to GitHub Actions, and we can monitor it here. You can see the payload once again here. The cluster name we're sending is dev, the region US East 1, and the action here is destroy. I have this already created within the self-service action, so we don't have to ask the user to put it in. And then we can take a look at our GitHub action. Here's the job that's running, and we're running. You can see Terraform destroy already, and that's going to go ahead and destroy our cluster with the VPC and everything we created with Terraform. It's going to get destroyed. And the important part is also that inside of our catalog, if you go back to the catalog, the EKS cluster itself, as you can see, got destroyed as well. So Because Terraform is reversing everything that it did in the beginning when it created it, it's removing this as an entity within port itself. This brings us to the end of this video. As you've seen, it's quite simple to wire up different backend actions to port's rich frontend. We built an EKS cluster, scaffolded a Node.js app, and deployed it to the cluster. I love the feedback loop that we get very easily with port in terms of firing an action in the backend and getting feedback in the front end, which is harder to do with Backstage. In our final video, we'll discuss the integration with Argo CD. As you may know, I'm a big fan of GitOps, and it makes sense to see how port works with Argo. Thanks for watching, and I'll see you in the next video.